All right, let's move on to vertical dilations. So for vertical dilations, we want to essentially do the same steps, but what a vertical dilation is you're going to stretch your graph vertically, so stretching it up and down or compressing it up and down. So you're either squishing it up and down or stretching it out. And what do I mean by that? So let me draw you the original happy face. Okay, so here's a happy face. If I'm going to vertically dilate this, let's say I'm stretching it out, okay? So this is a vertically dilated happy face. And I can also vertically compress it, which means I can make it shorter. So it stays the same amount of wideness. Okay, this is going to be hard to draw. Okay. It stays equally wide, but it just got a lot shorter. There we go. So it's the same width, but it just gets stretched up and down, okay? And so this is vertical, so we're going to be changing our y value. Notice that that means it happens outside of the argument, not inside. So our original graph is f of x is equal to 2 to the power of x. And then we are going to vertically compress it. Compress because this is a number less than 1. So when it's a number that's less than 1, it's going to make it shorter. So we're going to compress it vertically. And notice that this 1/4 appears right over there next to the y. So it's the y value that's changing. The y value is going to be multiplied by 1/4. So it's going to get smaller because it's being multiplied by a small number. Okay, so let's let's plot the 3 points. So our original point is 0, 1. X stays the same. 1 gets multiplied by 1/4. Okay, so what is 1/4 times 1? That would be 1/4. Anything times 1 is just the anything. All right, next number, 1, 2. The x stays the same. Oops. The 1/4 gets multiplied by 2. And so for here, your x stays the same, but 1/4 times 2 is technically 2 divided by 4, but this is simplifiable. So this is 1, 2 over 4 is the same thing as 1 over 2, so it's 1/2. And how did I go from 2/4 to 1/2? All I have to do to simplify a fraction is divide the top and bottom by the same number. In this case, 2 and 4 are both divisible by 2. So 2 divided by 2 gives me 1. 4 divided by 2 gives me 2. So I just divided the top and bottom by the same number to simplify. Last one, x stays the same. Y gets multiplied by 1/4. So x stays the same, and then we get 4 over 4, which simplifies to 1, because 4 divided by 4 is just 1. So now we have our 3 points, and I'm going to do my best to graph these fractions because it's a little bit harder to graph fractions. Everything's a bit squished. But 0, 1/4, I guess the whole point is that it's squished, right? 1, 1/2, 2, 1. So you'll notice it is getting a little bit higher, but it's still very squished. All right, so let's get our asymptotes, and then we can graph the complete graph. So we're going to write the equation. Notice 1/4 is just plopped onto the front of f of x. So that's exactly what we're going to do. 1/4 is just plopped, multiplied to the front of f of x. So it's literally just 1/4 times 2 to the power of x. Notice that there is technically a plus 0 here, so your horizontal asymptote is 0. That is not looking like 0. Let me do that again. There we go, a little better. Okay, so that's your asymptote. And now let me connect these dots. So it's a lot smushed, a lot more smushed. But essentially, this is what your graph looks like. Originally, it stood taller. It looked like that. but now it got smushed. Vertically smushed. And that's because we multiplied every y value by 1/4. We made it smaller. Okay, so this is a vertical dilation, more specifically a vertical compression. Compression because you're smushing it. Let's go on to number 4, which is a vertical dilation. Notice that the number we are multiplying it to is -4. Remember, a negative means it's going to be flipped. So not only are we stretching it out by a factor of 4, but we are also flipping it around so that it's got a vertical vertical reflection as well. So the negative is going to make it flip, and the 4 is going to make it stretch out because you're going to multiply everything by the -4. So the x stays the same. The y value is going to be multiplied by -4. Where did I get the -4? Right there. Okay, so all of these points are in the original equation f of x. Now let's see what will happen to them. X stays the same. Y value gets multiplied by -4. -4 times 1 is just -4. Okay, same thing for the next point. X value stays the same. Y value gets multiplied by -4. So -4 times 3 is -12. All right, pause the video, try the last one on your own. All right, so we are unpaused. You should have gotten 2 comma -4 times 9, which will give you 2 comma -36. All right, let's plot these points. Okay, it's very hard to plot these points, but I'm just gonna give it my best shot. 1 comma -12, somewhere over here. Wow, no, not there. Stop that. 1 comma -12 somewhere over here. 2 comma -36. I'm just gonna put that over here. Okay, close enough. My point is, look how stretched out this graph is. And it's gonna go close to the horizontal asymptote, but we don't know where that is yet because it's a little bit confusing when it's all stretched out. So let's write our equation out. Our equation will help us find our horizontal asymptote, which will then help us graph it properly. So g of x is equal to -4, just plopped in front of the f of x. So that's what we're going to do. -4 plopped in front of the f of x. That's our equation. Notice that our equation technically has a +0 at the end of it, so the horizontal asymptote is 0. So even though it's so stretched out, the horizontal asymptote did not change. So even though it might look like you just moved it down, no, you did not just move it down, you stretched it down. So it's still going to start where the 0 is, and then it's going to go like that. So this is the graph for number 4. So they're kind of different. Number 4 got stretched vertically and also flipped, but it got stretched vertically. Stretched because the number 4 is bigger than 1. And it also got flipped because it's a -4, because it's a negative. In number 3, we had a number 1/4. 1/4 is less than 1. So that means this one got smushed. All right? So if it's less than 1, it gets smushed. Greater than 1 gets stretched. Okay, so pretty similar principles will apply when we do horizontal dilations in the next video.